Hey Mayport Sharks, this is Miss Sluter, finishing the last lesson on volume. This is the lesson where we're going to take what we know on the volume of cones, cylinders, and spheres and apply it to real-world problems. So there's going to be a lot of problem solving. These are going to be multi-step questions, but secretly, these are my favorite. Our I can statement is I can use the formulas for the volumes of cones, cylinders, and spheres to solve real-world problems. So below we have two different cylinders that are fruit cups. And it says a youth sports club is holding its yearly tri-county tournament. The club is selling fruit cups in two different sizes. So we have our regular fruit cylinder and our large fruit cylinder. And we just want to compare the volume and the prices. So the first question says find the volume of the large fruit cylinder cup to the nearest hundredth and use the given diameter to find the radius. Use 3.14 for pi. Let's read that again. Find the volume of the largest fruit cup, so I know I'm talking about this one, to the nearest to the nearest hundredth, so we have to round to the nearest hundredth, 2 digits after the decimal, and it's already reminding us to use the diameter to find the radius. All right, so the largest fruit cup is giving us the measurement 7 as the height and 3 inches as the diameter. The 3 inches diameter, we need to solve for the radius. So the radius is diameter divided by 2. If the diameter is 3, 3 divided by 2 is 1.5. And now I have all the information I need to plug into my formula for a cylinder. Volume equals pi radius squared times height. Volume equals pi, radius is 1.5 squared times height. But we don't square the height, so it can't be that one. It has to be the second one. Next step, I want to figure out what is 1.5 squared. So if I entered into my calculator, 1.5 times 1.5, or 1.5 squared, gives me 2.25. So now I have pi times 2.25 times the height, 7. And if I plug that into the calculator, I have my radius squared, 2.25, times my height of 7 times pi equals 49.455, or in other words, 49.46, because remember we were rounding to the hundredths. And that would be the volume of the large cylinder. Now they want us to find the volume of the small fruit cup to the nearest hundredth by entering the correct numbers in the equation. Volume for the small cylinder is pi radius squared times height, which means I need to find what the radius is. Here, the diameter is 2.8 inches. If the diameter is 2.8, the radius is half of that, meaning my radius is going to be 1.4. 1.4 squared times the height, and the height of the small cylinder is 6. All right, calculator, because I need to know what is the radius squared. 1.4 times 1.4, or 1.4 squared, is 1.96. And I do not square my height. My height remains 6. But if I take all of the correct measurements and put it into the calculator, I have radius squared, which is 1.96, times my height of 6, times pi, 3.14, and I have 36.9264. But remember, it's asking us to round to the closest hundredth, so the 6 is going to tell the 2 what to do. 36.93. 36.93. Nice. Notice when I put it in the calculator, I did the order in whatever way I wanted to, because I can apply the associative operation to multiplication, meaning I can change the order and I'll get the same answer. So fill in the missing information of the table after completing parts A and B. We know that the regular size fruit cup is $3 with a radius of 1.4 and the volume of 49. Ooh, wait, hold on. Regular one is a small one, so that would be 36.93. 36.93. The large fruit cup. The large fruit cup was the one with the diameter of 3, radius of 1.5, and the volume of 49.46. So notice, the price difference is only 50 cents, but because the radius is just 1/10 larger, and of course the height was larger, now we're getting about 15 cubic inches more of fruit. So for 15 more cubic inches, you're only spending 50 cents more. Pretty nifty. Volume of a cone. I like this one too. Volume of a cone. A paper cone has a height of 3.6 inches and a volume of 2.028 pi cubic inches. So here they're giving us the height. Remember, height goes from the tip of the cone to the middle of the circle. And they're giving us the volume in terms of pi. And all they want us to do is to repeat what is in the problem. The volume of the cone is 2.028 pi. The height of the cone is 36 inches. And if we substitute the volume and the height into the equation, volume equals 1/3 pi radius squared times height, then our equation is going to look like my volume has to be 2.28 pi, 1/3 radius squared times my height, 3.6. Found it. Nice. So let's solve. I've got 2.28 pi equals 1/3 pi radius squared times the height of 36. Well, notice they took away the 1/3 here. And quickly they are taking 3.6 and dividing it by 3. 3.6 divided by 3 gives me 1.2. So that is my new height of my cone, 1.2. And remember, I'm solving for the radius, so we've got some problem solving to do. If I have 2.28 pi equals the height, 1.2 pi radius squared, and I'm looking for the radius, then I need to divide 1.2 pi to move it to the other side of my equal sign. So if I divide, it's going to look like a fraction like this. And notice I now have pi on the top and the bottom, which means it's going to cancel out. And radius squared is simply 2.28 divided by 1.2. So let's put that in our calculator. 2.028 divided by 1.2 gets me 1.69. 1.69 is equal to radius squared. Remember in the last unit we learned about how to undo the exponent. So in order to undo radius squared, I have to find the square root of 1.69. That's this fancy button right here. Square root of 1.69 is 1.3. So now I've identified that the radius of this cone is 1.3 inches. Ooh, so if the radius of the cone is 1.3 inches, what is the diameter of the cone? Remember, the radius is half of the diameter, or in other words, the diameter is 2 times the size of the radius. So 1.3 times 2 gets me 2.6. Perfect. And now we come to my favorite problem. if I have a cylinder that I place tennis balls inside, I now have two shapes that I can solve for the formula of the volume of the cylinder jar and the volume of the tennis balls inside. So we have this interesting question that states, Holly has an empty cylinder container. She places 4 tennis balls each with a diameter of 2.6 inches inside the container. What is the approximate volume of air inside the container? There's a lot of problem solving to do here. So you're going to have to take it step by step.
Write it down.
If I have a container with the height of height is 10.5 inches, and it's telling me that the radius of the container is 1.5 inches, then technically I can solve for the volume of this container. Remember, the volume of a cylinder is pi radius squared times the height. And I have my radius and I have my height, so I can plug that information into the formula to solve for volume. But what it's asking for is to determine what is the volume of air in the cylinder after I add 4 tennis balls. So if I put 4 tennis balls in this container, check out those tennis balls, then how much is the area of air, the volume of air around the tennis balls inside the container? Like my diagram here. There's one more thing we need to know. They tell us that the diameter of the tennis ball is 2.6 inches. If the diameter is 2.6, then what would the radius be? Because remember, in order to solve for the volume of a sphere, we need radius cubed. It is 4/3 radius cubed times pi. If my diameter is 2.6, then half of 2.6 is going to give me the radius, the measurement from the center to the outside. Half of 2.6 is 1.3. Okay, that means I now have my radius that I can plug into my formula to solve for the volume of the tennis ball. But then after I find the volume of the tennis ball, I have to multiply that volume by how many tennis balls are in the container. So once I find the volume, remember I need to multiply it by 4 tennis balls. And finally, my last step. After I identify the volume of the cylinder, what is the volume of the cylinder? After I identify the volume of the 4 tennis balls, then I can subtract to find the volume of air. That is what we're looking for. The air inside of the container after we put 4 tennis balls inside of the cylinder container. I'm not going to have time to solve this, but you know you'll have to solve it on your own later. Pay attention, if you solve for the volume of the cylinder, then you can solve for the volume of the cone, and finally you can subtract the differences to find the area of the air. Notice, here's your formula, volume of the cylinder. Take note, you need it for your questions. Find the volume of the tennis balls, volume of the spheres. Take note, you have to multiply by 4. You're going to need it for your questions on the quiz. And then finally subtract. Please pay very close attention. Good luck. Bye.